here we are, and as I said, thank you once again. A better picture than the one you saw before, and we want to make a fairly shortish presentation. So if you had a little comfort break, please come back and welcome. And we want to simply try to prove to you that DRM, which is Digital Radio Mondial and No Rights Management, is a solution for all coverage needs in all bands. And I'm trying to go to the...
I'll advance them. You just tell me when.
Yeah, the agenda. I mean, I'm not going to go through everything, but just to give you a bit of an idea what we want to touch upon, apart from the unique benefits of the standard, a few words about single frequency network, and people who are in radio, they will know what I'm referring to, and emergency warning, which is so important nowadays. As I said, DRM is for all coverage needs. So we'll also show you a bit briefly how it works in AM and also in FM, in band. And at the end, because we always heard that Digital Radio Mondial is great, but no receivers, we'll give you a little update on receivers and try to change your mind. So if you go to the next one, I think that I will very briefly mention that we are a bit like SBE, a not-for-profit organization, and we are, I think, the bunch of people who have a lot of experience and knowledge about DRM. Not the only ones, but you can guarantee that most of your questions can be answered by the DRM Consortium specialists. And you can always join our organization individually or as a company. Okay. Next one, please. These are some of our members. Of course, this slide has gotten very busy with some well-known names, but also with a few new ones. I'll just point to you Silicon Labs, for example, US company, or Dolby, also from the US, even Voice of America under the very long title of US Agency for Global Media, but also other companies like All India Radio here, or Technomedia, also from India. And lately we have been joined even by a company in Peru. So if you want to see your name here, please join us. So a lot of times we've been asked, so why should we use the DRM standard? By no means the only one, as we could see in the first presentation when we were shown the very efficient RF supercomputer. And I will try to very briefly answer this question, which will be answered actually throughout this presentation. First of all, DRM gives free and universal access to information, education, and entertainment. And I must say that during these COVID times, especially the information and education have come into the forefront. It also gives the possibility of covering a full country, therefore covering all the citizens in a country, not just the ones in the very big cities. It is a single technical standard for all the bands and for all the coverages, local, regional, national, and international. And as you will see, it uses spectrum efficiently at reduced costs. It is green, and it also offers much more than analog radio through its data capabilities and multimedia capabilities. Is also a gentler standard, in the sense gentler in inverted commas, because it allows for a smoother transition from analog to digital. You don't need, in other words, to buy all the new kit to become digital. So these are some of the arguments, and you will see them demonstrated in the next slides. Okay. Before we go to the standard itself, just to remind people where DRM exists, functions, is being rolled out, and much appreciated. And this is not an exhaustive list. India is the largest digital radio rollout in the world currently, mainly through the deployment of medium wave transmitters. There are short wave transmitters, and of course, a solution for digitizing FM is also under consideration. China will say that they are the biggest digital radio mondial country because at the moment, with 8 shortwave transmitters, not 7, they get the full country coverage. Pakistan is preparing the rollout of DRM, very interestingly, starting with FM and then AM, and they have a plan and the budget for it. And Indonesia has also tested FM, and at the moment has installed the first DRM for FM transmitter, especially using the emergency warning functionality, which is key for this country. There are other countries, of course, in Asia Pacific testing and looking at DRM. Nepal is one, Bangladesh another one. Vietnam has shown an interest, although it hasn't decided exactly what it wants to do. Going to another continent, to Africa, South Africa, as you know, has successfully trialed DRM in AM and FM, and the draft policy recommends DRM, not on its own, it is true, and we are hoping to see this draft policy as a real policy so we can go ahead with it. So let's continue with the next slide with some other countries. Russia, another big country, has mandated a DRM after a very successful test in VHF in St. Petersburg and several deployments after tests in Siberia. And DRM for FM was on air and will be shortly on air again in St. Petersburg. Hungary, as Chuck knows very well, has one of the largest shortwave transmitters in the country, and at the moment is also finessing a second shortwave trial in DRM from Budapest itself. I will not go through all the other countries in Africa, in Europe, and even in places like USA and Germany, where not only the audio but the data capability of DRM have been shown to work extremely well. So if you want more, we have more, but I will now try to move this presentation on and go to the standard itself and its features and pass you on to my colleague, the Vice Chair of the DRM Consortium, Alexander Zink. So Alex, I will mute myself so you can tell us a bit more about the standard itself.
Thank you very much, Ruxandra. Can everybody hear me?
Yes, loud and clear.
Okay, great. So let me request the controls again.
Go ahead and try if you can make it go. If not, I can move it.
Yeah, for some reason it doesn't work. Okay, let's move it. Some of the DRM key facts. Well, all of you know that from DRM as a technology, as an open standard, is in effect the successor technology, the digital version of both the classic AM and FM radio broadcast. It is an ITU standard for terrestrial digital radio broadcasting. And as Ruxandra already mentioned, it's the only standard that covers all the different coverage scenarios that you might have, from local services all the way to international transmission on shortwave. On a single frequency, on a single transmission, DRM can provide you with up to 3 audio services, plus multimedia services and PAD, program associated data. For the transition period, both in medium wave and the FM band, it provides for simulcast operation, where from an existing transmitter, you can then add the digital signal on the side. This is the way that All India Radio, for example, has started their national migration plan from analog medium wave using the same infrastructure that they could use for pure analog, now also for DRM. And at some point in the future, once the migration is finished, then the analog portion can be switched off and the full bandwidth signal can be used for digital, giving even better and more services. The whole DRM standard is openly standardized. It is not controlled by a single company or organization, which means for you as a manufacturer or you as a broadcaster, you get the equipment, you can start building equipment, or you just buy it as a broadcaster. You don't need to pay anybody for using it. It's just freely available. The technology is all taken care of, all the fees that might be applying by the manufacturers, and there is no usage fees whatsoever on the broadcast side, on the receiver side. Also, keep in mind that DRM is a standalone service, meaning that just like in classic AM and FM, one single broadcaster is in charge of their transmission. It is not a multiplex operation like DAB, where multiple services and broadcasters need to share a common platform. You as a broadcaster are still in control of your own transmission. This graphic here shows the different coverage scenarios just visualized, and all of them can be covered by DRM. From band 3 line of sight services all the way to shortwave international transmissions. Next one. And this visualizes the same idea here. We see the AM bands with long wave, medium wave, and shortwave portions. We see the VHF bands for more local and regional services with band 1, band 2, the classic FM band, and band 3, which in some parts of the world is used by DAB or DAB+. All of these bands are served by DRM, and important to understand, while the transmission modes are optimized for the physical conditions in these bands, the features and the functionality perceived by a listener are always the same. So everything I will show you in a moment going forward is available for transmissions on all these bands. Obviously, with a physical limitation, on a single shortwave, high robust transmission, you will probably not be able to do the full 3 stereo services just due to capacity. Let's move on. These are the key features as a listener will perceive them and can perceive them. First of all, there's more choice. I get, as I mentioned, up to 3 programs, audio programs, plus multimedia services on a single frequency. Now that opens up the opportunity for a broadcaster to carry on with the existing main program, then maybe add a more niche program for audiences that so far couldn't be served. And there might be a capacity even for a pop-up station if there's a big festival coming up, if there's a local event going on, you can advertise and tap into the advertisement with a pop-up station just for that event. You have the capacity once you have digitized. There is the option for simulcasting between analog and digital from the same transmitter. That is useful for the transition period. Obviously, our recommendation is that the simulcasting period should be kept as short and brief as possible, just to make sure you have enough receiver population in your target audience, and then switch over to full digital, because at that point, all the benefits of digital radio will fully kick in. Excellent audio quality. The point of DRM is that the audio encoding is defined and the quality of the audio is defined at the point in the studio where the content server sits. That's the audio encoder, data manager, configuration management system of DRM. At that point, the audio quality is determined. And then once you are with your receiver in the coverage area of that transmission, that is exactly the audio quality undistorted that you will hear. So the times of hissing and fading in digital are gone. There's even the option, particularly for local and regional services, up to surround sound.
You're not connecting.
No, can we go back? Chuck, can you maybe mute other panelists? Would be useful. Okay. Chuck, can we go back one slide? Hello, Chuck? Yeah, thanks a lot. So multimedia applications, apart from good audio quality, DRM gives us the option to transmit multimedia and data applications from sophisticated text information to images, to document distribution, firmware upgrades, whatever you envisage to do. On the one hand, that's a great listener benefit. You can, as a broadcaster, you can get much of the content that you generate and hold on your website and make that available right at the point where people are listening to your station in the radio set. Obviously, that's a great opportunity for extra revenues. Shifting the paradigm of radio financing and advertising from pure audio announcements to the whole world of media services. There are new ways that digital radio offer for service coverage with the SFN, single frequency networking approach. In the past, you had to put up a single high power FM transmitter, for example, in the city center. And if you wanted to serve a whole region, you had to request and pay for frequency licenses for each of these transmitters individually. With SFN, you can reuse the same frequency for a whole region with multiple transmitters with overlapping areas working on the same frequency and not disturbing the sound, actually improving it in the overlapping areas. Then there is the aspect of green and efficient broadcasting, where DRM in the FM band, for example, can save up to 90% of power compared with analog FM and still gives you the same coverage area and more services. Automatic tuning means that I, as a listener, I don't need to memorize the frequencies anymore. As a broadcaster, it means that you can get rid of necessarily advertising your broadcast frequency as part of the name, because that puts you in trouble if your station has multiple frequencies or is available in FM and AM. In the future, you advertise your station label, and I, as a listener, select that label from the list in the receiver, and then it's the receiver's task to keep me tuned to that particular service, even if that means switching frequencies or bands or standards. And finally, we learned that specifically in Asia Pacific, one key component of digital radio is emergency warning functionality, where your radio can switch on automatically in case there's a major disaster pending, can give you all the relevant information in multiple languages. So let's have a look at some of these aspects in more detail. More choice is the first one. Jack, next slide. This is the classic distribution paradigm that we know from analog AM and FM radio. You have your audio program in the studio created. There's the distribution network, and then you feed it to the transmitter. And as I mentioned, if you want to have a whole region covered in FM in particular, with multiple transmitters and overlapping area, there is no way around using independent frequencies, unless in very special situation like along a highway. Next one. In digital, this looks slightly different, as we have this additional component called the DRM content server. That's the head-end system, which sits at the end of the studio, the playout system of the studio. It takes in all the different sources from audio programs, from data, your web content, content management system, all of these things, playout system, all of them are connected to the content server. The content server then takes care of audio encoding, including lots of processing, monitoring. We heard about loudness adjustments before, so that can take place automatically in the content server as a last element in the chain responsible for the loudness. And the output, the distribution, long distance distribution to the transmitter sites, that is no longer an analog distribution link or a digital one, super expensive and high bandwidth. Instead, we are sending a signal called MDI, multiplex distribution interface, over any IP network from the studio to each transmitter site. That is very low bitrate compared with your classic audio distribution and can carry so much more information. Next one. Excellent audio quality. Let me just mention that DRM can do up to 5.1 surround sound, and it deploys the latest audio codec standardized by MPEG and ISO, which is called XHE AAC, Extended High Efficiency AAC. The benefit of that is that as a broadcaster, you don't need to decide in advance anymore whether you are broadcasting or going to create a pure speech content or a mixed type of content program or music program, in which case you had to choose a different audio codec and higher bit rates in the past. That is gone. XHE can give you the best possible quality and really very decent quality, even at ultra low bit rates, such as 8 kilobits per second. If you listen to that, for example, on the drm.org website, it is, in my view, pretty amazing what kind of quality you can achieve with these low bit rates. Next one. Multimedia applications, next. Here we have a set of standardized applications available in DRM that both the broadcasters should support and the receivers support. In addition to the ones listed here, the standardized set of applications, you can of course also use the DRM standard to distribute your proprietary specific application specific information. For example, DRM has successfully been deployed for serving multimedia and entertainment information to ships deployed around the world through shortwave, because satellite connections for those ships are way too expensive, and DRM really is the only way for people to stay connected to their families, and DRM is the perfect medium for that. But here we are looking at the standardized applications supported by the majority of receivers. Let's start with the text messages. That is small scrolling text information, such as the current audio song title and artist that you're listening to. Journaline, we will have a look at in a moment. That's the more advanced text information, more like an electronic newspaper or magazine, where interactively on your receiver, you can look up information on demand. Slideshow and TPEG, the traffic information service, they're more tailored for local services or regional services where we have a higher capacity, not so much for the AM band services. And finally, the EPG SPI is both program information, but it's also the means to distribute your station logos. So in the receiver, your station logo pops up instead of just the label. All in all, with these elements, particularly Journaline and text messages that are widely supported even on affordable receivers or in-car receivers, with these services, you can really generate new revenue sources. Next. And particularly with Journaline as an example, we want to have a look at how that looks like. First of all, at this point, I should mention that Journaline, as much as text messages and service labels in DRM, support Unicode coding from day one. So all the scripts in Asia Pacific and around the world really can be transmitted. We are now working on specific receiver profiles for different regions in the world, so that when you, let's say, as the regulator in Indonesia, you could come up with a policy that says digital radio sold in Indonesia need to support profile Indonesia, which means whatever specific fonts and characters might be required. Next one. Check, next slide. So this gives us a few technical benefits of Journaline. On the left side in the graphic, you can see some of the topics that All India Radio is currently transmitting through their DRM digital radio network to all the listeners. That includes, as you can see here, news, various types of news, sports information, updates, business information, but also the DRM.org latest information is provided here. On a more technical level, the Journaline standard is defined to work with very low bitrate requirements down to 200 bits per second, for example. So it really doesn't take away from the audio quality. That's one of the key elements, particularly in transmissions that have a strong limitation in bandwidth, such as over shortwave. As a broadcaster, you can reuse your existing data sources. Typically, you don't want to employ special people or staff just for editing Journaline content. And for most broadcasters, we saw that this content really is available. There is no need to generate new content. We just have to make sure that we can make it available on the receiver. So for that purpose, the content server that we saw earlier can tap into the various data sources that broadcasters already have available, whether it's XML-based information, RSS feeds, and other stuff. And finally, on the receiver side, the standard is designed so that even on very affordable embedded receiver solutions, it can be implemented without requiring particularly large amounts of memory or CPU power. In addition, there's extended information in Journaline available if you have a connected device, if you're listening to DRM radio on a connected device, such as DRM reception built into a Wi-Fi radio or a mobile phone. Then you can deploy the back channel, where with a push of a button, you can connect back with the broadcaster and subscribe to or find more about the advertisement that was given, by the tickets that you have been presented with, and so on. Geotagging allows to localize content that is useful for advertisements, but also for general information such as concerts going on, cinema times, weather forecasts, and so on. The geotagging feature is also used as part of the emergency warning functionality, where the affected area is specifically described on the first Journaline page of that emergency service. And finally, there's a feature called speech hinting, where the text-to-speech output of text information on the receiver side can be significantly improved. This is one of the features that were standardized with the help of BMW, Audi, and car manufacturers in general. So to make sure that even while driving, you have access to this kind of information without interfering on your attention or the traffic. After all, as a summary, Journaline enables efficient and on-demand text information services in digital radio. It is free to air and doesn't require any internet connection, which is particularly important for certain coverage scenarios and audiences in some countries in Asia Pacific, and also around the world, which don't necessarily have immediate access to mobile internet services, be it for cost reasons, for infrastructure reasons, or whatever. And in this context also is where we're now working with All India Radio to enable radio schooling distance education services through the use of Journaline. Next one. Typical types of content that you would provide through Journaline can be, if you want to categorize them, can be either general information, as I mentioned earlier, sports, news, weather, stuff like that, or it can be program-related information. The contact information to talk to the representative of the station, to call into the show if there's a talk show going on, all of that. Show background information if you have an educational editorial piece, and you want to provide background information for people to look up, or recipes for a cooking show, all of that can be provided through Journaline. Journaline is also the standardized, ITU standardized method for captioned radio in DRM, with subtitle and serving the hearing impaired or affected. Another aspect here with program-related information, if you combine that with the interactivity feature that I mentioned earlier, that allows a station to generate their own ratings. And those ratings on the program would be much more instant than what you get through the official channels. In Europe, for example, the ratings of radio are typically done twice a year. When listeners are called and asked, what stations have you been listening to over the past week? Obviously, that's a snapshot and is very, very delayed information. If you come up with games and interactive elements, polls and stuff where people can connect to the station right away, all these interactions would be channeled through a central routing device at the station, and all the interactions from the listeners therefore can be counted and plotted on a graph. So what you in effect get is an instant feedback. It doesn't necessarily give you the absolute numbers, just like these standard ratings, the classic ratings, but they give you a very good relative feeling of how your audience is participating throughout the day, how they are responding to certain program types and elements, advertisements, whatever you put out to them as a challenge and as an invitation to interact with your station. A very important element for some broadcasters that digital radio offers, while still maintaining the paradigm of broadcasting, meaning one-to-many or almost unlimited number of listeners. Next slide. The commercial benefits I mentioned, you can obviously have advertisements that you link to from your audio track. So the audio program could have an advertisement for some specific product, company, whatever service, and that could then link the listeners and send them over to Journaline to find out more, to be taken directly to the web page with a push of a button, to have them connected to a call-in line and all of that. Another element that is important to showcase the potential of Journaline for new paradigms of commercialization of radio is shown here. If you design your menu structure in Journaline, the menus and submenus properly, then at some point at the end of this menu tree, your listener has very clearly identified himself and categorized himself. For example, the first menu that I'm presented with when I enter the Journaline service on my radio is the language selection. So we are in India, there are 27 or so main languages, and I select my preferred language. Obviously, the local one plus English would be the top ones presented to me. Then I can select the region I'm in if I want to read about regionalized content, cinema times, weather, and so on. And finally, what is my topic of interest that I'm searching for at this moment? Is it the cricket sports results? Is it the cinema times, and so on? At this point, when I sell an advertisement for this particular page or a sponsorship, the listeners that are accessing that particular page have clearly categorized themselves into speaking whatever language, in which region they're interested in, what topics they're interested in. So the placement of ads on these pages is much more valuable and specific than what I could otherwise achieve over broadcast. But keep in mind, still the whole Journaline service is part of your broadcast service. So everybody receives the information. It's just how the user uses the information and accesses the information that helps to make this service so valuable. Next one. Good coverage, SFN. Let's have a quick look at how SFN works. Next one. The technical basis, as I mentioned earlier, single frequency networking is that you have multiple transmitters with overlapping areas serving an area. And all of these transmitters can now work on the same frequency at the same time, fully time synchronized with the same content. And in the overlapping areas, instead of destroying the signal, we actually see an improvement of the signal strength, which also means that compared with the analog case, you could move the transmitters even further apart. We just did a calculation for a highway project, and it shows that only a third of transmitters would be required for digital radio compared with an analog coverage of the same stretch of highway. Very significant. apart from saving power and all of these benefits. So how can this SFN paradigm, how can it help in today's scenario? Let's say in a city, you have one big transmitter tower at the moment. In effect, you have to increase the power from that transmitter over proportionally to be able to cover the outside areas, the parts of the city that are further away from the transmitter. And if you have some hilly terrain and some shielding going on, there's little you can do. You're just losing those areas unless you get another frequency and set up another FM transmitter. That was the situation in analog. In digital, thanks to SFN, if you have a hilly terrain and some parts of your city are shielded, you put up a small gap filler transmitter, ultra low power, that works on the same frequency. Nobody needs to switch frequencies, and that fills you these areas perfectly that are within your licensed area, but not covered by the main transmitter. Or if you think about further deployments in the future where you come up with whole new network planning, if a city can be covered with multiple lower power transmitters instead of one big transmitter in the city center, the overall capacity and the overall power that you spend can be significantly reduced and still give you an overall better quality of coverage. Next one. This is an example of one specific additional benefit called network gain. As long as you have these multiple transmitters with overlapping areas, even if one of them should fail and be out of service for temporarily, the other transmitters would at least still serve the areas with overlaps. Next one. Automatic tuning, I mentioned earlier, it's a convenience features and it follows the service even if I leave the coverage area of the current transmission that provides me with this service. Next. And finally, emergency warning and alert. In DRM, this feature is called emergency warning functionality. How it looks like as one of the essential features of DRM is what we see on the next slide. This is the task that we need to fulfill. We want to warn in case of pending disasters. We want to warn the public and of course authorities and public services with a maximum reach as quickly as possible and with all the relevant information. This is the task. And we believe that radio is uniquely positioned in fulfilling the tasks. Radio, of course, is only one way of reaching the people in these scenarios. Of course, you will put the same warning information on your TV services, on your mobile services, and so on. But each of these distribution mechanisms has unique limitations, and radio, as it is reconfirmed all over the world again and again in cases of catastrophes, is the one medium with the maximum reach and the best possible reach in very dire situations where otherwise the whole communication would be shut off. So how can digitizing radio specifically with DRM help you in improving its use for these emergency situations even further? Let's have a look. Next slide. The Open Digital Radio Standard, DRM, has all the elements already on board that we need for this kind of sophisticated emergency warning functionality. Next one. So it's not a new development, it's part of the standard. This is how it works. In the affected area, that's the yellow patch in this map, there may or may not be local services still available. But one of the benefits of radio is it can reach and serve those areas from outside due to its unique physical conditions. We have long distance coverage, we have strong transmitters outside. So the whole network can be built in a very resilient way, even if some of its elements are no longer available. That's different, for example, from a mobile phone network. If some of the local base stations are off, then you have no mobile service, period. What happens in this scenario is the authorities determine that there is a disaster pending, be it an earthquake coming up or be it a shore region where a tsunami is rolling in, and you need to inform the people quickly. In that case, what happens is the receivers are explicitly told with an alarm signaling to retune to the emergency program. This alarm signaling is broadcast on all the transmissions covering that affected area, even private stations, public stations, doesn't matter. The emergency program itself is only put up by one station, typically a public broadcaster. Once the receiver has retuned, it will present the audio, which obviously is one language at a time only, with only the most important headlines. Now, if you remember our task list, it doesn't give us the full service yet. We wanted to reach all the people as widely as possible with all the relevant information. And this is how digital radio can really improve. Because in addition to the audio, we also provide detailed text information, which helps us to reach the hearing impaired, which helps us to reach people that don't speak the local language that is in the audio track. So if you're traveling internationally or even within the country, if there are multiple regions and languages spoken, you still get the full information. And finally, it helps to take off the load from the emergency response agencies, because here we can provide very detailed on-demand information that otherwise people would be calling in for and cause unnecessary delays in getting the information out and also occupying the attention of those response teams that really should focus on other things. For example, if a tsunami is rolling in DRM with this text information Journaline, you can quickly look up the locations of shelters in your region. You don't need to call anybody and be in a log line. One key benefit in addition that I haven't mentioned yet is this alarm signal is in a special place in the DRM transmission. So even if your receiver is in deep standby mode, for example, at night when you're sleeping in your sleeping room, your DRM receiver is in the main living room, it can switch on automatically and go to full volume, wake you up and give you that information. A very crucial information and piece of feature that obviously in analog is not possible. Next one. Let's have a look now. So far, we looked at the features from a listener's perspective. Now let's have a look at the transmission side very quickly. Let's start with the large area coverage and international coverage that DRM can provide by deploying the huge physical benefits of the AM bands, but bringing all these huge features and benefits from digital radio to these bands. So we are looking at long wave, medium wave, short wave. Next one. The true benefit of digitizing these bands is that you are providing effectively FM quality, at least FM quality sound within the coverage area that is the same or larger than your previous analog coverage area. So if today you have an AM station and your audience is turning away because the quality just doesn't make it for them, they are used to internet services, FM quality services, stereo sound, that's a challenge. You have two options. You can either migrate to an FM station that is very local and you would lose probably large chunks of your coverage that you had before, or you could digitize your AM service and in that case retain the same coverage area, maybe even improve it, but still give people FM quality. And along with the service list that I mentioned earlier, from a listener's perspective, it doesn't matter whether at that point, whether the transmission is received over FM band or AM band, it's just digital radio with similar features, same features and similar quality as any local FM station. Probably the most important part here is that DRM in the AM bands is very flexible to cater for the different coverage scenarios and frequency needs. And the bandwidth that we receive from these services is about 25 kilobits per second, roughly, for those who have a technical eye. The on-air bandwidth can be your standard classic analog on-air bandwidth, 9 or 10 kilohertz. So DRM is designed, as you can see, to fit with the existing generalization. But it also serves double bandwidth scenarios in some Asian countries in particular, where 18 or even 20 kilohertz bandwidth per station are already the standard assignment. And DRM can make perfect use of them by using that bandwidth now fully, other than the analog services. Next one. Let's have a very quick comparison that shows the savings potential. In a classic medium wave transmitter or coverage scenario, of a 100 kilowatt medium wave transmitter, you could get a coverage diameter of 600 kilometers. Now, this is very rough rule of thumb, just as an idea. The same coverage could be achieved with only 40 kilowatt of DRM power. Actually, if you look at the ITU documents, they suggest that 20 kilowatts will already be enough. It depends on your coverage scenario, the configuration that you've chosen. Next one. And if you plot that now graphically, so instead of one analog service consuming 142 kilowatts of actual power that you need to pay for, if you look at a 72% efficiency of the transmitter installation, in DRM, we achieve up to 3 audio services plus multimedia with only 50 kilowatts of consumed power. And that is a huge difference if you have to pay for this difference every day and every week of the year. It really sums up. Next one. There is on the HFCC, the shortwave management board that aligns the frequency use worldwide. And with HFCC together, the DRM Consortium has come up with a world map that shows the different transmissions. So you can click on the different regions of the world and see what DRM transmissions are currently available on shortwave in your particular area. Since it is in cooperation with HFCC, unfortunately, it doesn't include medium wave and FM local services yet. Maybe one day it will. Next one. So the summary for the AM bands, we have wide area coverage. We can reuse to some parts existing transmitters and infrastructure, antenna designs, frequency assignments, regulations, all of that can stay in place. The energy savings are significant. You can save 60%, maybe 80% of analog AM power with the same coverage in digital, but giving you then up to 3 programs and extra benefits, plus all the extra savings on maintenance, spare parts, and inventory. Next one. Now let's have a look at DRM for local services and regional services in the VHF bands, particularly, obviously, digitizing the FM band. Next. Next one. The use of DRM for band 1, 2, and 3 is in VHF bands is also endorsed by ITU. Not only the system description is available, but also the network planning parameters. So if you want to start planning your own DRM-based transmission networks in the country, you get all the planning parameters, both for the AM bands, but also for the VHF bands. In the FM band, we are also looking at interference potential with analog services. And in band 3, we're looking or have covered interference potential with DAB services. So all of that is available for you, readily verified to use. In this case, for the VHF bands, the bandwidth of our signal is fixed to 96 kilohertz, so 100 kilohertz nominal, which means that it's only half the capacity, the bandwidth that you need for an analog FM station. And still keep in mind, it gives you up to 3 audio services. The useful capacity is up to 186 kilobits per second. And again, we have this good trade-off between capacity, coverage, transmission power, where you can fine-tune the broadcast and transmission parameters based on what you need for that particular coverage need. And again, there's an easy transition path, even for established FM networks. Next one. The flexibility of the configuration is shown here very briefly for you as an overview. There are 2 modulation modes and 4 code rates. If you look at the graphic, the horizontal axis shows you the top one, the achievable capacity in kilobits per second between 37 kilobits per second and 186 to the right. And to receive these particular configuration signals properly, you need different levels of SNR, signal to noise ratio, meaning the quality and signal strength of your received digital radio signal to be able to decode the content. And then to the top, we have the various code rates, meaning operation points for our on-air configuration. As you can see, these 8 different operation points to configure your DRM signal really well cover the whole bandwidth from low capacity, very robust, ultra robust signal for very challenging, demanding coverage scenarios and needs, all the way up to very high capacity, but more demanding in terms of signal quality configurations for the areas like a small village, city, or community station, where really the coverage terrain and scenario is not the biggest challenge that you have. And you have the luxury of going for maximum capacity. Next one. This shows us the power saving potential of DRM. And for the FM band, actually, that's even bigger than for the AM bands. In this case, we are looking at a 10 kilowatt FM transmitter analog on the left, which uses 200 kilohertz of on-air bandwidth, frequency bandwidth, to provide us with one audio station. In comparison to that, in DRM, we are looking at roughly only 1 kilowatt of transmission power to give us the same coverage area, of course, depending on our configuration. So that saves us 90% of transmission power, but consumes only half the bandwidth on air and gives us up to 3 audio services. That shows the potential for broadcasters by simply digitizing their existing FM stations. Next one. Next. Chuck, can you move on? By the way, can everybody still hear me? It seems that some people have an issue listening to me. Okay, I can only hope that you can still hear me. Let's see. On this slide, I'm presenting to you how the transition can work. Within the existing FM band, how you can insert digital radio services using DRM. What it shows you is that in the gaps between FM stations, there might be enough space for additional DRM services. And I will show you a real world example of that in a moment. What this graphic also shows you on the right side, here we have 2 DRM services or transmissions with a capacity of up to 6 audio programs occupying the bandwidth of a single FM station. Now, typically, if we were to use independent DRM transmitters, of course, there would need to be some safeguard in between those transmissions. However, with modern FM transmitters, having a linear capacity of up to 600, 800 kilohertz of bandwidth, definitely more than 400, you can place multiple DRM signals side by side on a single transmitter. This is one of the configurations currently being discussed for India, where there is enough space between the analog FM services distanced at 800 kilohertz of separation, and the DRM signals, and the analog FM sites are already shared between different broadcasters. So each has their own transmitter, and then there's an output combining and then fed to a single antenna for all these private stations and public broadcasters. Using to DRM, now even the transmitter can become a shared infrastructure part, where each broadcaster provides their independently controlled, configured, and managed DRM MDI signal to the site, but the actual amplification, the transmission part, is carried out for multiple of these DRM broadcasters with a single transmitter device. Of course, that's a huge efficiency improvement possible with DRM. Next one.
Alex, I heard you just now. Try it again.
Okay, great. Can you do the next one?
Okay, happy to.
Thank you. So here we go, and this is the real world example that I promised, how you can place DRM signals in an already seemingly overcrowded FM band. This is a snapshot of the FM band in Johannesburg. And as you can clearly see, there is no gap for any additional analog service unless you put it on the same frequency as an existing one and just add to the overcrowding of the signal and the interference of the stations. However, if you inspect closely on the next page, you can see that there are small gaps where there's enough space for a digital signal, which only occupies 100 kilohertz. And this is exactly the scenario that was tested in Johannesburg with a community station called Kofifi FM. Here you can see that the DRM signal was placed in between two pretty high power FM stations. And the testing of that signal, when we did the measurements, proved that both the DRM reception was not interfered with by the FM stations, but more importantly, the analog FM stations had no interference from that rather low power DRM signal at all. So that was the very encouraging outcome of that trial. The report is also available on drm.org if you want to read the details. On the next slide, we can now see if you go through the spectrum, you will find actually 16 of those small gaps that you could still use for adding digital services, which effectively means that in this overcrowded band, which doesn't seem to accept any more services at all, there is still enough capacity for an additional up to 48 extra radio programs. And that's pretty mind-blowing. Particularly if those can then be assigned to the existing broadcasters who can extend their services, benefit from the multiple programs per transmissions, all the data applications, while for the time being still keeping their analog services on air, just to make sure that the transition is smooth. Next one. So in summary, DRM for the FM band and local services, of course, it's an ITU standardized system. It's the successor technology of analog FM services. It reuses existing infrastructure, transmission infrastructure. It reuses the existing licensing model for the band. And it, most importantly, carries on with the established business model. It doesn't require broadcasters to join multiplexes or anything the like. It allows for new planning opportunities for the network and for new structural approaches, for example, using SFN, single frequency networking. It can bring down the cost of operating your transmissions very significantly. Not only does it reduce the power required by up to 90%, as we've seen, and if you multiply that cost saving with the number of stations and, and possibly programs, that can be very significant every year. But it also means that by using the smaller power transmitters, you save on all the surrounding costs, from cooling to site space to maintenance, all of these. So lots of cost savings for the total cost of ownership from a broadcaster's perspective, in addition to the capability of providing more program space for your services and additional possibilities like Journaline to create revenue streams. Transmission equipment is available. We've heard earlier from Chuck that Eleanor's transmitters are perfectly capable of broadcasting DRM signals. So all you need to add possibly is the content server in the studio, and you're good to go on air with your DRM services. Thanks. Next one. And with that, I hand over to Radu to talk about and look at the situation of receivers, what's available in cars, desktop radios, and mobile phones. Thanks a lot.
Thank you, Alex, and good afternoon for Asia, and good evening or even good night for the United States, and good morning here in London in Europe. As a way of introduction, thank you first of all to Ruxandra and to Alex for making the introduction to DRM. It is, as you heard, perhaps the newest radio standard, a global radio standard, open standard, and therefore receivers are maybe not available in such quantities as older standards have. But things are changing. And also, as a way of introduction, it is important to understand why receiver manufacturers are sometimes reluctant to produce receivers, and suddenly they are willing to produce such receivers. It is important that the stakeholders in the country rolling out or planning DRM, they announce it, they make public, they communicate to the industry the intention that that particular country is going to launch digital radio DRM. Once the manufacturers are trusting that they trust that something is happening indeed in a country by rolling out a digital standard, then they are going to plan and roll and produce those receivers. Next slide, please. This was the case in India. I mean, you saw that India is the biggest digital radio rollout at the moment, and it is with DRM because it covers already 600 million people approximately. And in some 2 years, over 2 million cars are already have DRM receivers in them, line fit. That is because the industry has watched and saw the development and the rollout and the installations and the commissioning of those transmitters all over the country, and they trusted that this project is viable, that is indeed happening. And also, they are witnessing at the moment that Pakistan is doing it, that Indonesia is doing it, that China is doing it quite, I would say, successfully all over the country. So there is the confidence in the manufacturing industry that DRM is being rolled out and planned in many other countries. So they are embarking on putting receivers either in cars or in desktops. So as I say, in India, there are over 2 million cars with DRM receivers. Next slide, please. Some of the manufacturers or the brands are listed here. I'm going to go quickly through them. Hyundai, Maruti Suzuki, Mahindra, and MG are some of them who are already on the road in India. And what is very important in India, for instance, is that the DRM receivers are coming at no cost to the consumer. So the car is being sold with those receivers in them, unlike in other countries in Europe, for instance, where you have to pay an additional fee for having a digital radio installed. Next slide, please. These are some of the Hyundai brands, models on the road. Next slide. Maruti Suzuki. These are some of the models. They have much more models on the road in India. Next slide. Mahindra has got only one model, one SUV, SUV. Next slide. And the latest brand is Motor Garage's MG with a SUV model called Hector. What I want to say is also that a lot of other international European car manufacturers are planning to install DRM receivers in their cars, which obviously are going to be installed, sold in the countries which are rolling out DRM, not only in India, but in other countries as well. Next slide, please. In terms of desktop and other car receiver solutions, either DRM only or as multi-standard, these are some brands like Gospel, Avion, Starwaves, RF2 Digital, Intot in India, and obviously Fraunhofer AS in Germany. Next slide. The first receiver, DRM receiver produced in India was done by Communication Systems, and the name of the radio is called Avion, and it is ready for mass market production, obviously based on substantial orders. That is important to understand as well, because we get a lot of questions, or the manufacturers get questions on the price, which is absolutely natural to ask for the price. But a unit price just for one to be produced is going to be much higher than if orders, substantial orders are placed when the price is going to go down by volume. So that is valid for every single radio manufacturer. So please bear this in mind when talking about costs of a receiver. There is a video describing and showing this receiver produced by Communication Systems in India, and you see it here in blue on at the bottom. If you copy this, once you receive the copy of our presentation, you can put it in the browser and you can watch the video. Next slide. One quite successful manufacturer at the moment for digital radios for DRM is Gospel in China. It is for all the bands, for DRM in AM and FM bands, also for the analog AM and analog FM. It's got the latest audio codecs, XHE AAC, and also the Journaline, which was very clearly described by Alex. And very important, especially for Asia, the EWF, which is the emergency warning functionality. Again, in red, it's very important to understand that if you would like to have receivers in your countries, then substantial orders must be placed so that mass production is produced and the prices are going down. Next slide. New set of receivers by Gospel have been presented at the BES Expo and conference in Delhi this year, at the start of this year. And these are the models which Gospel, unfortunately, due to the coronavirus, could not come along and actually physically present them. But we had a very good video which showed all the other models that are listed here. So there are desktop receivers, as you can see, and at the bottom in blue, there are car receivers, one aftermarket and one OEM. They're all for all the bands, DRM in FM or DRM in AM, and of course, in the analog version as well. Next slide. All these new receivers have the same functionality, all the features of DRM, Journaline, advanced text, the latest audio codecs, XHE AAC, and the emergency warning functionality. Next slide. Something which was attracting a lot of attention is the car adapter. So old cars can get a car adapter from Gospel, GR227, which has all the functionalities of DRM and can be installed in the old car, and actually through Bluetooth it can connect and you can have digital reception in your old car. Next slide. Another receiver manufacturer is called Starwaves from Germany, and Starwaves, in cooperation with Nedis of Netherlands, have presented several models of their receivers at the same BS conference and expo in Delhi at the start of this year. These are some of the models that you can see, and like Gospel, they also have DRM in both AM and the FM bands, have the latest audio codec XHE AAC, and the Journaline advanced text, and of course the emergency warning functionality. Again, I have to stress that if you want to have a lot of receivers, then substantial orders should be placed by the countries which roll out DRM so that the prices go down and the receivers are cheaper than just one unit. Next slide, please. A new receiver manufacturer is Intot Technology in India, and they are planning and working on 3 solutions: automotive, consumer device, and also smartphones. Next slide. And there is a video link to this, and you can see it at the bottom of the slide, which is in blue. Again, if you copy this, this link into your browser, you can watch the video about the INTOT receiver. Next slide. In terms of mobile solutions, perhaps Alex would be best to talk about it, but I will not ask him to do so. He's Fraunhofer IAS is working on a DRM receiver solution with built-in Wi-Fi hotspot, which can be used in tablets and also in mobile phones. And it was also presented at the BES Expo in 2019, so a year ago. And if you want to have more details, please copy the link which you see at the bottom of the slide into your browser, and you can watch the video describing exactly what it is all about. Next slide. Also, Fraunhofer IAS has produced a public signage service, basically big screens which can be placed anywhere in the street or in shopping malls, wherever, which is based on Journaline, having a standard DRM feature, and it can advertise, it can show all sorts of programs which are for public usage. It supports also the emergency warning functionality. It activates the audio. It cycles through all the information of the emergency warning. So it is a very useful tool in such cases. Again, there is a link to a video which is quite exhaustive, so you can see all the details about this service. And please look at it, because it is quite something. Next slide. And I pass it on for the conclusions, and to Ruxandra again to see why should you use DRM for your countries. Ruxandra.
Thank you very much, Radu. We are running a bit late, so I'm wrapping it up very quickly. If we can go to the next, probably final slide, and thank you very much for your great attention. DRM for your countries, why? It's more programs on a single frequency, and you saw how, with excellent audio and data, which was demonstrated. And for the regulator, this means all coverage, whole country coverage, plus emergency warning, plus the possibility of introducing DRM and creating a new industry. And of course, broadcasters are interested because they want more capacity, more ads, more choice, more programs on the air, but paying less for the energy, for the electricity, and that is possible. And we strongly encourage local receiver manufacturing, as you saw in Radu's presentation. And so if you go to the next slide, if you want to find out more, we have a new version of the handbook, version 5. Please go to Handbook DRM Radio and get it from there. And if you go to the next and final page, we will be able to tell you that you can follow us, can get the information, and now can ask questions if there is any time available. Thank you once again to Elenos, all the other participants, to Alex and Radu, and we are, as I said, at your service. We can give you all the information you need. Thank you very much.